All right, let's get started on probability. So I've snipped the problems that they referred to on the final exam study guide. So let's take a look. We want the odds in favor of obtaining a 4 when a single fair die is tossed. So there's 6 outcomes when you toss one die, 1 through 6. All right, we know probability of getting any one of those is 1 out of 6. We know the probability of getting a 4 is 1 out of 6, but it doesn't want probability, it wants odds, okay? Odds in favor of getting a 4 would be 1 to 5, okay? So getting a 4, and then it's favorable to unfavorable. So getting a 4, not getting a 4, okay? The odds against obtaining a 4 when a single fair die is tossed would be 5 to 1, okay? All right, another one they suggested we look at is 11F. So let's look at that. Odds in favor of getting an odd number when we spin this spinner. All right, so there's 2 odd numbers, okay? Out of 3 would be a probability. If we're doing odds, it would be 2 to 1, okay? Remember, odds would be favorable to unfavorable. Things that are favorable to the event would be 2 possibilities, unfavorable 1 possibility. So the odds would be 2 to 1. Then they suggested we look at 12E, odds in favor of event E. So let's see what's going on here. So we got a group of preschool children with 9 girls and 7 boys. She's going to select one child to be first in line, with E being the event that the one selected is a girl. Okay, so 9 girls. Okay. All right. So, and it was 12E. This is the one with odds in favor of selecting a girl. So there's 9 girls, and then there's 7 that are not girls. So that would be the odds in favor of getting a girl. All right, then it suggested we look at 49 to 54. So Anne randomly chooses a single ball from an urn shown here. Find the odds against each event. Odds against each event. So let's do the even ones here. Odds against getting a yellow. So there'd be 1, 2, 3, 4, 5, 6 that are not yellow to 1, 2, 3, 4, 5 that are. All right. Odds against red or yellow. Odds against being red or yellow. So red or yellow, or not being red or yellow, would be 2. Okay. And then being red or yellow would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 to 9. And then odds against being red or blue would be, yellow to red or blue. That's what we're looking for. So favorable to unfavorable. Okay, odds against being red or blue means you have to be yellow. So that would be 5 to red or blue. 1, 2, 3, 4, 5, 6. 5 to 6. All right, and those were odds. Okay. And then 59. Let's look at 59. Odds in favor of this. All right, so suppose we have some event, and the probability of the event is 0.37. That's really 37 hundredths. Okay. So odds in favor of E would also be starting with 37, but it would be to 63. So it'd be favorable to unfavorable, where probability is favorable out of the total outcomes. Okay. All right, then the next chunk was finding probabilities that are not conditional. So just a lot of probability problems we're going to look at. I'm going to do the even ones. All right, so let's look at 8 and 10. All right, we want the probability that the spinner would land on yellow, red. Let me do it in order. All right, red, probability yellow, probability blue. We're going to do that for each of these. Probability of red, probability of yellow, probability of blue. All right, so on this one first, notice the areas of the regions are the same size. There's 1 red one out of the 4 equal regions. There's 2 yellow ones out of the 4 equal regions, and there's 1 blue one out of the 4. and then simplify. So the probability of yellow would be 1/2. All right, on number 10, the probability of red would be 3. They're all equally sized also, but there's 6 regions. That would simplify to be 1/2. Being red or yellow is equally likely. They're both 1/2. And then the probability of being blue would be 0 since there's no blue ones. Okay. All right, 15, 17, and 25. Let's look at 15. 15. So we have these records, all these different people. If he randomly selects one record from his collection of 50, find the probability that will be each of the following. Okay, so I had to pay more attention. So 1 by Smiley Lewis, 2 by the Drifters, 3, okay, so let me write them down. 1, Smiley Lewis, 2 from the Drifters, 3 from Bobby Darin, 4 by the Coasters, and 5 by Fats Domino. Okay, and we want, and he's got 50 records. Okay, and we want the probability that it will be, each of these. So it's 1 out of 50. Drifters, 2 out of 50, and then simplify. Okay, or Fats Domino would be 5 out of 50, and then simplify. So you got the idea on that. Okay, on 17, number sums for rolling 2 die. So for that one, it's rolling 2 die. So you would look at that table that shows those sums, right? So I'm just going to do 1 or 2 of these. So remember how it has like the dice possibilities. It has a picture of the dice. And then it's like if you get a 1 followed by a 1, a 1 followed by a 2, and so on. Okay. And then like a 2 followed by a 1, 2 followed by a 2, and so on. Okay, so you can go to that. You've got it on your formula sheet. Okay, so let's say we're looking for the probability of rolling a 3. We would notice that on this diagonal, we have the rolls where the sum would turn out to be 3, because if you added those up, you'd get 3. So for B, there'd be 2 possibilities out of the 36, which would be 1 over 18. Okay. And if they wanted the probability of getting, say, 10, you would go to all the possibilities. You would see them on a diagonal, and you would have like, let me think where it would be. It would be way here at the end. You would have 4. I'm just going to list them. I can't go to the chart, so I'll just list them. So you would have, you can't do a 1 with anything because you don't have 9 dots. So it would be like 3 and 7. It'd be like 4 and 6 is one possibility, 5 and 5, and then 6 and 4. Okay, those would be the only possibilities you would see that would add to be 10. And then you would say to yourself, okay, so that's 3 possibilities out of the 36, and reduce that to 1/12. Okay. All right. And then finally, 25 was one where you were doing experimental probability. So 200 seeds were planted, 175 germinated. Then the probability a particular seed of this type will germinate would be 175 out of 200. And if I divided by 25, I would get, let's see, that would go in there 7 times. That would go in there 8 times. So that would be the probability. Okay. All right. The next objective on probabilities talks about conditional probabilities. So it said to look at 5 through 14 and then some others. Let's look at 5 through 14. Single number selected at random. What's the probability selected, or set A is that the selected number is even. B is the event that the selected number is a multiple of 4. So let's list those. Even would be 2, 4, 6, 8, 10, 12, and 14. Multiple of 4 has to be divisible by 4. 4 times 1, 4 times 2, 4 times 3. 4 times 4 is outside of the universal set, the sample space. Prime numbers, 1 is neither, 2 is prime, 3 is prime, 5, 7, 9 is not because it's divisible by 3, 11 is prime, and 13 is prime. 15's not, because it's divisible by 3 or 5. Okay, so those are the sets that would be representing each of those events. Okay, so I'm going to do the even ones. Probability of being in set B would be 3 out of those 15 numbers. The 15 numbers comes from here, so that would be 1/5. The probability of being even and a multiple of 3, I said it wrong. The probability of being even and a multiple of 4 would be 4, 8, and 12. Would be 3 out of 15, which would be 1/5. The probability of being a multiple of 4 and prime, okay, multiple of 4 and prime would be 0. No numbers in common to these two sets. All right. Let's look at the probability. Let's go over to number 9. Probability of being even and a prime number. Okay, there's one number that's in both of those. So even and a prime number would be 1 out of 15. Okay, now here's the trickier ones we did. So this means probability of being a multiple of 4, given that the number is even. Okay, so I'm looking at number 12 right now. Multiple of 4, I'll do 14 down below. Multiple of 4, given that you're even. So that given that statement is like reducing your universal set, your sample space, to those. So what's the probability that you're a multiple of 4? Multiples of 4 would be 4, 8, and 12. That would be 3. But instead of dividing by 15, you're dividing by the even. So this is your denominator. How many are even? 1, 2, 3, 4, 5, 6, 7. So 3 divided by 7 would be the answer to number 12. All right, let's do another one of those. What's the probability of being even? So this is the probability of being even, given that you're prime. Okay, given that the number is prime. So you're starting with this set of prime numbers now, and you're thinking about, well, there's only one even one out of the 1, 2, 3, 4, 5, 6 prime numbers. So that would be the answer to 14. Okay. All right. And then they suggested we look at this one, these problems 31 through 36 that relate to this chart here. All right. So the probability of being male, let's see, would be 52 out of the 100, and you would reduce that. I'm just not going to take time to do that. Motivated primarily by creativity. Okay, that would be 38 out of the 100. Not motivated by money. Okay, so not motivated by money would be not this, which means these two. Okay, which means motivated by creativity and giving to society out of 100, and that would be 69 out of 100. Okay. Female, now this is where these are the ones that are trickier, given that the primary motivation is a sense of giving to society. So let me change colors. Let me clean up this chart. Okay, so given that statement, given that the primary motivation is a sense of giving to society, would be this. Female would be that. So 14 out of just 31. You restrict yourselves to just looking at that portion of the chart that has to do with giving to society. Okay, on this one, the given that statement says the student is male. Let me change to purple. Given that student is that the student is male. So for that one, you're going to be focused on the male students, and motivated primarily by money would be 12 of them out of the 52 male students. So that what's after the given that statement, that's your denominator. And then you reduce also. Okay. All right, let's go ahead and look at the last one they recommended we look at, which is cards. All right. And they said, look at 47 to 53. All right. So let's go ahead and look at several of these. So we're talking about cards that are dealt one right after the other. We want the probability of each thing happening. So this is spade is dealt second, given that a spade was dealt first. Okay. So you might be thinking, okay, so for my first draw, there were 13 spades out of the 52. And then this is what we want. Okay, so suppose that happened and that was a spade. Then aren't there only 12 spades left out of the 51 cards? That would be your answer to 47. Right? Club dealt second, given a diamond dealt first. So there's 13 diamonds out of 52. That's my first draw. And then club dealt second. Well, the diamond was picked first, right? Club dealt second. There's still 13 clubs in the deck, but there's only 51 cards. Okay, and that's what's important, is that without replacement. I should have mentioned that. So your answer on 47 is 12 out of 51. Your answer on 48 is 13 out of 51. Okay. Now this one says probability that you're going to get 2 face cards. So this is going to be, well, there's 12 face cards out of 52 on the first draw. On the second one, there's only 11 face cards left and only 51. And so you would actually need to multiply those. Let me go ahead and do this one and simplify. Okay, 12 divided by 52. 12 over 52 times 11 over 51. And that would be 11 over 221 once it's simplified. Okay, no face cards. If there's 12 face cards, okay, then that means that you have a 52 minus 12, or 40 that are not face cards, okay? And then the next time around, there's only 39 that are not face cards out of the 51. Okay, and then you would simplify. All right, first card is a jack and the second is a face card. First card being a jack would be 4 out of 52. Now a jack, you assume a jack has been selected. You're not replacing still, right? All of these are without replacement. So there's only 51 cards left. And if you picked a jack, that means there are not 12 face cards left. There's only 11. And then you'd simplify. First card is the ace of hearts. Ace of hearts, that's 1 card out of 52. Okay. All right. And so that's multiplication. So you'd multiply these. The second card is black. Well, there's only 52 cards left. I mean, only 51 cards left because you picked one already. But all the black ones are still left because an ace of hearts is red. So you would do that, multiply, and still simplify. First card is black would be 26 out of 52. Second card being red would be 26 out of 51, and then you'd simplify. Okay, so if I did that, I'd get 26. I would take 26 52nds times 26 51st, and I would get, after I simplify, 13 out of 51 for my final answer. Okay.